Hello everyone, my name is Dustin. I'm a student here at CVTC in the Automation Engineering program, and this is one of the labs we had to do for control applications, and I will create a short video here for you so you can see what it looks like. Alright, so here's the overall process from the lab that we did. We got a ball shooter. It uses two pancake cylinders to shoot the ball and catch the ball. We have two different controllers that both have the Click PLC on them. And then we have the GS2 drive, which is down here. The controllers here are connected as the master and then the slave. This PLC is actually giving off the power supply to this one. We had some issues with this PLC not wanting to run, which we found out was because basically the different power supplies don't coexist with each other with like the sine waves and stuff like that. So we had to take the power supply off this one to make it the power supply for this one, which is connected across right here. So since the power supplies are connected with this wire down here, if you start the process and hit the E-stop, it will drop the power on both sides of the PLCs. Likewise, if you do it with this one, it drops power also. So power-wise then, from this PLC, it will send power to the drive, which is over here, which comes through their outputs over here, which will send the signal to the drive to start at 30 Hertz, and then it will ramp up to 60 Hertz once the timer in this PLC is done. So for that drive to work, start the sequence by hitting the green button. That'll shoot. And then the outputs come on. But after the timer is done, different outputs change. The green light is the receive for the master program, which will tell the drive to shut down. Just as a quick overview too, these are the programs that we use in this lab. This is the master program for the PLC. This right here is the PLC program for the slave PLC. And then this is the AutoCAD electrical schematic that we used for the slave PLC. And then this one is for the master PLC. And then the master control relay, which controls the power going to both sides of the controllers. And then the schematic for the GS2 drive. And then the Flex 4 also. With this lab, I think it's a pretty good lab for 4-semester students. It encompasses a lot of everything we've learned over the couple semesters we had. We used pneumatics, electrical wiring, setting up the GS2 drives, PLCs, which is a big part of this, and a lot of the setbacks we had with this lab was making sure the power supplies work together. At first we tried using a separate power supply in each PLC, which that didn't work, and talking to our instructor, he said that basically the two power supplies don't want to coexist with each other, and that for this lab it seems like you'd fix one problem and create about 3 more problems with it. So that was always a bit frustrating, which caused us a lot of headaches, but we got through it, finally got it done, and I think this project will be something good for fourth semester guys.